All right. Good morning, good afternoon, good evening. We're going to go ahead and go through chapter 6 today, which is files and exceptions. And then we're going to go through the PowerPoint for this video and discuss it. And then, of course, we're going to have another video where we demonstrate it. So let's go ahead and begin with that discussion with files and exceptions. So basically the chapter is about working with file input and output. One main thing that we use a lot is loops to process the files because there are multiple things in the file to process, and one of your main tasks with files is the difference between binary and text, and of course multiple pieces of information that you're reading and writing to from the file. So we're going to discuss both of those today. Let me throw a little reminder up here for me that we're going to also discuss binary verse text. So when we get back to the whiteboard, we'll talk about that. And here we are. So when we save to the disk, we're going to be saving to a file, and on DOS systems that file has to have an extension. It's usually .txt, .doc, and here's the thing that you want to do, and that is immediately, and I'm going to do this in demo mode too, is go to your File Explorer, because this is often the biggest problem students have, is if you notice these just random files that I have up here, they have an extension, like this one's a .ppt. And that's because I've gone up here to my view, and what I did here is I just opened up File Explorer. So I went down here and I typed in Explorer, and I opened up File Explorer. To view your extensions, this is, especially being a developer and, working towards being computer savvy, viewing extensions is your most important part of a DOS operating system. You don't have to really worry about that too much on like a Unix system or a Linux system. But in our File Explorer, we want to go to View and then Show, and file extensions should be checked. You need to see your extensions so that you know what type of file you're writing to. Typically, if we are working with a binary file, we end it with the .dat extension, or you can just make up one. You can make up, if you're working with a binary file, that means you're developing your own proprietary file system. So you can make up your own extension if you want. Some of the common ones, docx, that's a binary Word document. And while you're here, go ahead and hit hidden items, but the big important one is file name extensions. So when we're outputting to that file and saving data and getting data from that file, we're going to be performing those two operations on what is called the file pointer. And you can think about the file, because the file isn't like a nice thing that you look up, and typically we're going to be discussing a text file. So I'm going to bring up Notepad, and Notepad, a text file is, something where you would have data maybe either separated by a line or whatever. And now you notice that there's these nice separations of lines. What you don't see is when I hit the enter key, a \R is actually going in there, and that's called a carriage return in the ASCII code. So you don't see that happening. So essentially a file, when you're thinking about a file, it's not nice and neat. It's one big long stream. So let's just take, for instance, a couple numbers. The number 23, I hit enter and I put in the number 43 and then I put in the number 54. What does that actually look like in a true file? Well, let's kind of look at it because I'm going to be visualizing the file like we look at it here in the notepad, but it's actually kind of like this. It's a circular representation because that's the way a disk is, and there's no real nice, neat lines for you. What actually happens is, let's go to the whiteboard. Think of it as a disk. Oh my goodness, that is a horrible disk. Let's actually draw a disk, please. Thank you. Yes, let's do that. Okay, so you can think of it as the number 23. Okay, this disk isn't working out. Oh, that's because I haven't finished it. Okay, there we go. The number 23 is put in. Then a \R is put in. And then number 43 is put in. And then a \R is put in. And then the number 53 or whatever I did it. So that \R, and it's really hard to kind of see that that's a \R. \R again. 23 \R, 43 \R, 53. That is, it looks all nice and neat here, but on disk, it's actually a circular pattern. And it's only shown in the editor nice and neat because the editor knows to look at 23, look at the disk, see the \R, and render the values 2, 3 here, and then skip a line and then render the values 4, 3, or draw it. So it's actually rendering that space for you when you hit that enter key. That's not actually what you save to disk. So you've always got, when you're working with text files, you always have formatters in them. And even the HTML tag language works with formatters. So when we look at the different formatters in a text file, what you can do is you can look at ASCII code, the ASCII code chart. And the ASCII code chart will show you some of the common formatters that we work with in a text file. Because a text file, we only work with these characters, 128 text characters on your keyboard. There are no more characters that go into a text file. It can only handle this 128 different characters. If you want other characters that are not accessible in like Notepad, you have to use a different editor that uses a markup language like HTML, or Microsoft's own proprietary markup language for a doc or an RTF. But when we're working with programming and saving to and from a text file, not only are you programming with a text file, even though we give it the last name of .py, it's still a text file and it's limited to these characters only. You can't put any special characters in an editor for a program. You would have to use the character codes if you wanted to inject special characters into your program. So the character codes for the low-level ASCII, that is at the very lowest level of all character codes. Even if you go to China, they use ASCII at the lowest level. And they have their special character codes that are built on top of that. So if you look here, we've got a carriage return, that's number 13. We have a tab, that's number 11. We have spaces are 32. Spaces is the value 32. So mostly what you will see is a \T. That's how we refer to it in programming when we're working with a carriage return that's given the value 13, we use \R. When we're using a tab, we use \T. A space, we just hit the space bar. So there are special formatters that you're going to be dealing with that you do not see in the notepad. It actually puts the \r in there, or the value 13 as a char. So this \r goes in there, but you don't see it in the editor. \r. Now, if we hit tab here and we do 45, that means that actually in reality we have a \t here, and it looks like this in the file. This is the way it would actually look like in the file, even though it would look just like that in the file on the disk. And then when Notepad opens it up, it knows to see that \r or character code 13 and put a new line. And then it sees 43, renders 43, sees \r, new line, renders the new line, or renders 43 under, or goes to the next line to render 54. Then it sees the \r, new line, and then it says the \t. So then it knows that it needs to render the 45 5 spaces to the right. So there's a lot going on that you don't see in Notepad behind the scenes with a normal text file. And these are the two formatters you'll see the most of, and you will have to do like some strip slashes. Let's back up a little bit. When I say the \r, I'm kind of talking Unix systems, because in DOS systems they do a \r/n. So new line, carriage return, new line, \r/n, because we have moved towards being more Unixy, we have removed the \r so you mostly just see the \n. So when you're working with files, you're going to see that \n pop up a lot. So I know I started talking about \r, but mostly what you'll see that you have an issue with is that new line carriage, or the new line character. And DOS predominantly has that coupled with a \r and \n. You may see it on legacy systems, but primarily if you're working on a newer system, it'll be just the \n that you see. So let's back up even further. And it's a good thing I kind of made that mistake, because you know that \r is the carriage return, but \n is the actual new line. So let's kind of take that back and let's get some better chicken scratches here. So this is primarily what you'll be seeing with what we just talked about. So 23 \n, and let's make this a little simpler to draw. And then we'll have a \t here and the number 45. So what does that look like on disk? Okay, well, on disk you will have that number 23, the \n for new line, then you will have 43, and do we have a new line there for that one? Yep. Then you'll have the \n. Then we'll have a \t. Okay, that \t is a little odd looking. Okay, and then we'll have the number 45. That's primarily what you're going to be dealing with. Now here's the thing, is when you're reading and writing from a file, that \n is going to crop up, and you're going to have to strip it out and deal with it as you're parsing and tokenizing. And when I talk about parsing and tokenizing, I'm talking about moving through the file and grabbing the data out. And we have a natural delimiter here, which is that \n, which is your carriage return. And again, you may see \r and \n on legacy systems because DOS primarily puts both when you do an enter, when you hit enter. But I think they've changed it. So you mostly will be dealing with I'm pretty sure they changed it. You'll be dealing with the \n. Okay. So what does that look like? Well, this is what it would look like on disk. Then we would render that, and it would look like this. Boom. Oh, 45. Oh, I got an insert key on. 45. Okay? That's how saving and loading to from a disk kind of works at a lower level, and I'm talking about text files. Okay, let's get into a little bit more on the PowerPoint. And we talked about this. So a binary file is a little bit different. So in a binary file, let's say, and I'm going to go ahead and bring up Visual Studio Code for this, just to give you an example. So let's say that we create an integer number 3. Oh, this is a text file. I'm going to go ahead and save as a Python file. This is just a play Python file. I'm going to throw that on the desktop real quick so we can actually run it as part of our discussion. Okay. Okay, so I create a variable called x, and x is a number. It's 4 bytes. It's a short integer. In Python, you don't have to tell it what data type it is. You can just declare it and assign it, and what data type it is comes from what you assign the value. So this is a number, and let me see if I can't. I'm trying to zoom it in for you here. Okay. Okay, well, I think it's good enough. We got x equals 3, print x. Okay, that runs good. So this x equals 3. Let's say that we're going to output x to the disk. What a text file does is it takes what's inside of x, the value 3, converts it to an ASCII value 3, converts it to its ASCII value 3, which if we look at here, the value 3 in ASCII is 51. And it takes that, and it takes that 51, and that's what it actually writes to disk. So it takes what's inside the variable and outputs it. And that value 3 is only 1 byte. So the text file, if we were to output that value 3 to the text file, it would only be 1 byte, and it would have the value 51 in it, and it would render the value 3 to the screen, even though we're storing the number 51 inside of it, because 51 is the ASCII code value for 3. Okay. That's a text file. A text file will take what's inside the variable. Binary file is different. What a binary file does is it outputs the whole x value, the whole data type. It doesn't output what's inside of it. It outputs the whole variable, meaning that it outputs, instead of 1 byte, it outputs the full 4 bytes that variable represents. And that means that if we're using 4 bytes to store that number 3 on disk in a binary file, that means we can update it to 32,000 and only use the 4 bytes that that variable takes instead of 1, 2, 3, 4, 5 bytes that the ASCII code value representation of what's inside of X takes when we output as text. So the difference between text and binary is binary, you can update the values in the file without changing anything else in the file. And that's why it's used. So that we can go to a specific location in the file, just change what we need in the file, and nothing else is changed. And we call those random access files. And it's actually what we used as RAM right before we actually had enough RAM to do what we do today. So we would actually use binary files as RAM, random access memory, for variables and whatnot. It was draconian. Because we didn't have enough RAM to store variables in. It was, programming back then was all about doing as much as possible with very little memory, because we didn't have much at all. So that's why we use binary files, is so that we can randomly change values inside of it, because we can update the X value at any time programmatically. And we're still using the 4 bytes that initially comes with that variable. So the difference between text and binary, text outputs what's inside the variable, converting it to the ASCII code values. Binary outputs the whole variable so that you can update that variable in the file without messing with anything else. And then you can get out of the file and use it like a database. In fact, that's how databases are made. That is a database, is a random access file. Okay. Sequential access and direct access. So direct access means it can jump directly to any piece of data. That's binary. That is being able to jump around in the disk. Sequential access can be used for both binary and text. Direct access can be used for both binary and text, but predominantly if we're doing text, we're using sequential access. That's the big thing that we're dealing with. So we're going to get more into that sequential as we progress and we start talking about the file pointer. And then the direct access is more of a discussion for binary files. And we'll get to that when we talk about pickling. Okay, file name extensions. We already discussed this. Now the file object is the actual file variable that we create to access the file. And that the file object is also what I call the file pointer. And the file object will always sequentially point to the very end of the last read or write sequence in the file. Okay, so you see here in this example, they're talking about the file object. Now, again, file object and file pointer mean the same thing to me. So I'm going to be using file pointer when I discuss this. But from your book, you can refer to it as the file object. This is the sequential access of how a file works. Now for that, we're going to go to the whiteboard here. Okay, let's say that I want to output hello world to a text file. Now I'm using this as an example instead of this disk thing because it's just easier. So let's just say that this is our file, and just pretend it's a disk. The file pointer is what we use to access it. Now the file pointer is always going to start at the very beginning. Now it looks like I'm having an issue here with my, oh, here we go. That's what I needed. Okay, so the file pointer is going to begin pointing at the very beginning of the file when we open it for reading or writing. When we do a read or a write, the file pointer then moves to pointing to the very last read or write that we just did. And we can read or write \ns inside of here for a new line. Or it can be, I mean, those have to be explicitly done if you're going to actually inject a \n so that you have a new line between these two. And we'll be playing with that in the demo. But every time you do a read or write, you can think of the file pointer like your eyes in your pen. So for your eyes, that is your read. For your pen, that is your write. So you only, that's a horrible W. You only open up a file for either read mode or write mode. Binary files can handle both read and write mode. Text files, we only open up for one or the other. Mostly. I'm not for sure. Yeah, so let's just keep it that simple. So you can think of the file pointer as like your eyes when you're reading. So when you read a book, you start at the very beginning of the page, and then as you read, you usually read one word at a time. And so you have a natural tokenizer where you're creating tokens based on a natural delimiter that happens to be this space. And that can be used for our read commands, that natural delimiter, that space, to where you perform multiple read commands to where you read one word at a time. You can read the whole thing at once and then parse and tokenize it, or you can read one word at a time and use that natural space, \n, as your delimiter. Now, so think of reading with the file pointer or file object as your eyes. Think about your pen as what you're using for when you write. If you are to output, your pen moves as you are outputting the data. And so when you go into to do another output, like you output hello, your file pointer goes here, then you output world in the loop, and your file pointer goes over to here after it's output the world. And then your next output will start right here at the end. So it's really kind of simple. The file pointer acts like your eyes in your pen. That's all it is. And so it's an implicit thing that happens that moves along every time you do a read or a write operation using the read or write function of the file pointer object, or the object, or the file object. The read or write function of the file object. Okay, so that's kind of the mechanics of how it works. So let's go ahead and continue on. But I'm going to take a quick break and come back, and we'll continue on with PowerPoints. All right, well, welcome back. It's a good thing I took a break because that was probably the most important discussion that we had about files and kind of how the mechanics work. So let's talk about actually what we are using for the file pointer or the file object. So the open function is what we will be using to open up a file. Now here's the thing, this file name, this is where you're going to always have a problem, because you should be just using the file name so that it opens the file in the current directory that your program is in, your PI file is in. You should never have to do stuff like C blah 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 / my folder, whatever. It should just be myfile.txt or something like that. And then you're going to give it a mode, a read or write mode. You're going to do if you're going to read from the file, you're going to do an R. If you're going to write from the file, you'll do a W when you use this code. Appending, what appending does is it automatically moves the file pointer or the file object to the very end of the file so that you can add to the file instead of the file pointer beginning at the very start of the file when you open it in read or write mode. And that's kind of how the appending works. So the appending is just working with moving the file pointer to the end of the file when you open the file, because by default, whenever you open up a file, the file pointer always starts at the beginning of the file. So if we go back to our chart, the file pointer will always begin here at your beginning of the file, unless you open it in append mode, where it will go to the end of the file and append. Okay, now this is where we get a problem specifying the location. A lot of students have this issue, and I already kind of talked about it, but you should not be using C:\\/ my folder / myfile.txt. What you want to do is you can do that with the prefix R for a string literal, so you don't have to do the \\\. And let's just talk about that real quick, because that is a very key point discussion in this. So let's say that we are going to be opening this file. Okay, and you're having problems opening the file because you have not been working, you've been working in the editor and you haven't really learned very well how to work in the folder. And so the big issue would be that the file, the text file, exists in the same file as or the same folder as your Py file. That's why we open it up implicitly in this manner. And we open it up for write mode. Okay, now I changed that because when I did a copy paste, it got some weird characters in there in Unicode. Most editors can't see, if you use just a straight notepad editor, it won't see those special characters if you do a copy paste, but Visual Studio Code will, and it will cause you problems. So be very careful when you copy and paste code in. You saw how the difference in how it worked or how it looked. So this is the way you should be opening a file. You should be storing your file in the same directory as your Py file. So my Py file, and you can see the directory it's in. It's in C users bjosh desktop. So I should have myfile.txt in the desktop folder with my play.py file. And if you do that, this will work. If you don't, you will have to do something like this. C:\\. Why do I have to put 2 backslashes? Because \n is a formatter, meaning new line, and your interpreter doesn't know what you mean there. So you gotta tell, oh, I really mean a backslash. So you put 2 backslashes instead. And then you would have your myfile.txt in the C file. Well, some people don't like the dual backslashes and it's confusing. So then you put R in front of it to mean that it's literal. I think you do it actually over here. And then you can take out the backslash and it'll work. But guys, seriously, do not do this. Do this. Put it in the same folder. You don't want, because especially if you are going to give this script to somebody else, they're not going to have that file in the location that you have it. So it's expected as common decency that you open your file implicitly, telling it, don't go anywhere. Don't go to C drive. Don't go anywhere but the place that you know exists. And the only place that this interpreter knows about and when it interprets your file knows about is the folder where your actual Py file is at, which is on the desktop. So I would put my file in the desktop folder so that I can implicitly open the file without having to put C:\\. And this is the biggest mistake that students have all the time when they're opening up a file, and the biggest problem that they deal with. Okay, so that opens the file. That discusses a little bit about what the R is for. Read only, this guy right here. Prefix the path string literal with the letter R. That's what that means. So I showed you an example of that. All right. So when we write data to the file, we use the file variable and we use the write statement. In this case, our file variable is the file object. Now, I'm just kind of a little bit on the anal side, so I'm going to call this pointer. But actually, file object is probably the appropriate term working with Python. But we all know that this is just going to a C program that actually creates a file pointer for it. So when you say file object, it actually becomes a file pointer when it gets to the C level. Okay, so when you do a read, you're going to be doing the same. You're going to be using the read method. So you're going to use the write method, and then you're going to be using the read method. And the read method brings in that \n as a, when you use the read line method, it will read up to the \n. The read method will read the entire file. So we're going to probably demonstrate with the read line, but you can use the read method to get in the whole file, \ns and all, and then tokenize it with maybe the split function. The read line method will adjust the file pointer in the file every time it hits a \n, and it will continue on with another read line until it hits another \n. But it does return that \n, so you got to strip it of the \n when it comes in. So for example, if we are using the read line method to read these two numbers, I'd call the first read line method, and it would read the first number and give me the \n at the end. And then I would call it again, but since there is no \n here, it's just going to give me the 00 because I haven't hit enter there to get the \n. And again, when we demonstrate, that's going to become a little bit more clear to you for our next discussion. Okay, so mostly you are going to get that \n when you do a read line or any kind of read method. And so you've got to use the rstrip method to strip it out and get it out of your read call or your read line call. So when we work with the W mode, opening a file, if the file exists, it's going to overwrite. It's just going to overwrite what is there. If it's not created, then it creates the file. So if you open it with a write, if the file doesn't exist, it'll create it. If the file does exist, it's going to open it and start the file pointer at the beginning of the file and overwrite anything that's in it. And then the file pointer moves along every time you call the write function. So numbers, when you read a number from a file, you will always have to convert it from the character version of the number to its integer or float. So remember we were talking about how when we output to a text file, it converts it to ASCII. Well, when you read the number 10 from a text file, it comes in as the value 3130. So that means that if you have the number 10 in the text file, it comes to you as 10 that's actually a string. It's not a number. It comes to you as a string, an ASCII code. So what you have to do is when you read that number from the file, you have to convert it to an integer or if you're using 10.3, a floating point value. Because when you output numbers to a text file, they convert to the ASCII code equivalent. And when you input numbers from a text file, you've got to convert it back from the ASCII code equivalent to an actual number that you can put on the CPU and process. Okay, so loops are something we use to process files. Often we will have to call the read line method multiple times to read everything in the file, unless you do a whole read and parse and tokenize with the split method. We can use a for loop for reading, but the best thing to do with a text file is a while loop until you get to where nothing is being returned. So that's why we'll use a while not equal to, and we'll use an empty set of quotation marks. Now I'm going to do a no and copy right from here, and I'm going to get some weird characters. Well, line does not equal to, and let's just do that. Okay, there we go. I think it's just, oh yeah, okay. Line equals that, okay. I think maybe we need to do that. Okay, well, we'll come back to that in a little bit. That's for demo mode. But essentially, we will have read commands. Now, guys, I'm not doing this syntactically correct. But what we'll do is we'll have something like line is equal to file pointer dot read, and of course we need to open it for read. And what it'll do is it'll read a line at a time. Oh, this has got to be read line because read will read the whole file. It'll read a line at a time until it gets to the end of the file. And every time it reads a line, it assigns it to the line variable. So the first thing that you're going to do is we're going to print the line every time through. And that way, what I'm doing is I'm reading the information, then I'm printing the information. Now, guys, remember that this is going to read the \n. You won't see it if you print it. Well, you will see it. It'll show a new line, but you'll think that that was on purpose. But it's in there. That \n is in there. And again, we will look at that during our demo video. So you will have to strip it. So what I would do is I would do this. I would strip. I'm just going to do it in comments. Strip \n, then print. And add a new line for the next print. Because you don't want to tokenize a word with a \, a formatting character in it. You're trying to get the words out of the document, not the special formatters in the document. Or not the document, the text file. Okay, so here's a little bit of a we use the read line to read the first line from the file. Then we continue to read until we get to an empty line where the line has no value in it. That means that we've gotten to the end of the file. Then we close the file. Okay, so here is where we get with a for loop. And we can use a for loop for the amount of lines that are in the file object or the file pointer. And it iterates over each line in the file. This might be the most safe one to use. That is the least likely to have an error. So we'll demonstrate both of these when we get to it during our demo time. Okay, a record in a field. This is interesting words. I call them tokens. One piece of data within a record. A record is a set of data. Okay, so you can think of a record as being a word that you read on in a text file. So if you have a word in the text file, that is a record. If you have a 10.4, that is a record. Now what's a field? W is a field inside of the record word. 1 is a field inside of the record 10.4. And that's the way the book is using it. I would call them tokens and characters and chars. That's pretty much at the lower level how we refer to them. Okay, so when we're working with records, we want to be able to add records, display records, find specific records, and then modify or delete records. When we're working with those steps, what can invariably happen is errors. So what we have is a way to detect errors, and often, let's say that we are expecting a number, but we get a word, and we try to convert that number to its ASCII, or that word to its ASCII, but it's not an actual number. It'll throw an error. If we try to open up a file that is not found, it'll throw an error. And that's where exception handling comes in. And that's why we use the try statement. Now, when we use the try statement for exceptions, we can catch the error that happens when we open up a file for reading, and let's say the file doesn't exist. Or if any other kind of error happened in our block of code, such as, let's say we read in a number, or what we expected a number, but it was characters. Like the number, let's say that we were expecting to read in 10.4, but instead, we got a word, Adam was there instead of 10.4. And let's say that we tried to convert that to a number when we read in Adam, but we can't convert that to a number because it's characters. So the code, the method that converts it for us back to its numerical value from its ASCII, will throw an exception that we need to catch so that we can show an error that something unexpected happened. So when you're trying to open up a file for reading that doesn't exist, because we know if we do it with write, it's just going to create the file and overwrite. Or when you're trying to do a conversion or any other type of error that happens, such as something that never happens anymore, which is running out of disk space. That kind of error used to be the predominant one that we always check for, and now people don't even really do it because there's so much disk space out there. But any kind of error, we use a try catch statement. So we use the try statement, and we put in our statements to open the file, convert the documents, everything to work with that file inside the statements of your try catch exception blocks. So that is what we refer to as our try catch handler. And again, we're going to demonstrate that when we get to it in another video. But this is how you need to handle for errors. And also, it's expected that you use the try catch when you are getting information from a user validation. Let's say you expect the user to type in a number, but they type in a word instead, and you try to convert it to a number, because the way all input and output works to and from the user is if you output a number to the user, whether you're in a graphical user interface or in regular console mode, you always needs to convert to its ASCII code equivalent before it can be drawn and rendered on the screen. And then if you are getting information from the user, it always comes in as the ASCII code equivalent, as the 128 keys on your keyboard, which is why there's 128 of these guys. And then you got to convert that input to an actual number that you can process, add the value 10 to it, and work with. So that is where we get into the try catch handlers. And of course, we're going to handle exceptions and demonstrate that as we progress. So I'm going to actually put in here a note, because we're going to use this code. I'm going to say demonstrate try catch statements. Okay, that is one thing we're going to add, and we're going to also deal with some of the file folder stuff. So we're going to be handling that and displaying exceptions in our demo type with the else clause, in our demo with our else clause. Finally, this is kind of like, hey, if everything went okay, then let's go ahead and clean up before we exit. So the try, and the try is where you put the code you were going to do. The accept is if that code that you did in the try had an error, it's going to catch that error. And the finally is when everything is cleaned up and ready to go. You close your file, etc. So those all work with exception handling, throwing errors and stuff. And of course, that really has to be shown during demo mode. And that's something that we'll get to for that video. So if an exception is not handled, guess what, guys? Your program stops working. And invariably, that is why we are using Python. Python is an interpreted language. That means it is hyper able to come back from errors. That's why JavaScript is used for web programming. Interpreted languages are what we refer to as bulletproof, because it'll have two layers of error handling. One at the interpreter level, and then the other at your level where you're programming in that language or script. So the try-catch clauses are something you need to do for every input you need to look at. And that especially goes for cybersecurity, because input validation is the most important thing you can do for security of programs. And cross-site scripting is a good example of that. And that's beyond the scope of our discussion here. But that's kind of the lowdown of chapter 6. We will get into demonstration mode in our next video. Thank you very much, guys.